We have learned a lot about the M and the B letters in the y equals mx plus b equation. This week we will focus on x and y. Okay, so we've been studying this equation for a few weeks now. We've been talking about the m and the b. We've learned that the b is the one-time number. It's also called the y-intercept. It's where you start on the y-axis when you're graphing a line. We call the m the over and over number, and it tells us how many to rise and how many to run when we're graphing a line. This week we're talking about the x and the y. Now you've dealt with x and y for probably several years now. The x and the y numbers are just the numbers that make up an ordered pair. Alright, you've seen ordered pairs. Say I have like 2, 1. The 2 is my x number and the 1 is my y number. And we've learned that x man moves either left or right. If he's sad, go left. If he's glad, go right. So this 2 is positive. He's glad. He would go right 2. And you do that first. And the y man moves either up or down, up with a smile or down with a frown. Since this 1 is positive, he's smiling, he's going to go up. So on a graph, you would go 2 to the right, starting at the origin. You always start at the origin when you're graphing ordered pairs. You would go 2 to the right, and you would go 1 up, and you'd place your point there. And that's what ordered pairs do. Okay, so these same numbers that are part of an ordered pair, this x number is the same x that we have in our y equals mx plus b equation. Okay, so you've seen the x number. It's the same x number in an ordered pair, and it's going to be plugged in here in our y equals mx plus b equation. So if we were using this 2, 1 example, the 2 would replace that x letter and it would go into a math problem. Okay? By the same token, the y becomes a number in the equation here. So what we're learning about these ordered pairs that you may not have known before, this y is the result of this x number being put into a math machine. You plug in a number, you do your math with your m and b numbers, and out comes a number that we call y. And that's how we get these ordered pairs that you guys have been using since middle school. Okay, we'll be doing more and more of that in the future. The thing to remember, the most important thing to remember is whenever the value of x changes, it causes the value of y to change. So x happens first, x changes first. As a result, the y happens second. The y changes second. Alright? Let's go ahead and look into different ways x can cause the y to change. Okay? In some situations, when the x gets bigger, it causes the y to get bigger. And when the x gets smaller, it causes the y to get smaller. Okay? So basically, if we were drawing arrows, if x is getting bigger, y is getting bigger. Okay? And if x is getting smaller, y is getting smaller. Easy enough. Okay? These are together, and these are together. Okay? They're always going the same direction. We call that a positive correlation. Okay, now we've learned about positive slope, and positive correlation is very similar to positive slope. In fact, they look the same, because this direction, x numbers are getting bigger, and this direction, y numbers are getting bigger. So if x is getting bigger and y is getting bigger, we end up with a positive slope, and we call that relationship a positive correlation. So if you have dots that are gradually going uphill like that, you can call that a positive correlation. Alright, it doesn't always happen that way, however. Let's take a look at the next possibility. In other situations, when x gets bigger, y gets smaller. Okay? X is getting bigger, but y is getting smaller. They're opposite arrows from each other. Or when x gets smaller, y gets bigger. So the x is going down, but the y numbers are going up. This is called a negative correlation. And it looks like this, okay? When y is real big and high up in the sky, the x is low, way down here. X is like 0 or small numbers over here, y is really high. And the bigger the x numbers get, the smaller the y's get. So we have a downhill looking slope, and the relationship is called a negative correlation. So it's a negative slope, and it's also a negative correlation. So that's all there is to that. Let's look at a few real life type examples where we can kind of see how this would look. Alright, first example, Josh goes running every morning. The calories he burns during a run depends on the distance he runs. Okay, so we're going to just narrow this situation down into the two things that are happening in this situation. The first one, Josh goes running. The second one, Josh burns calories. Now what has to happen first? Okay, before he can burn any calories, he has to go running. He goes running, that happens first. Okay? And what happens second? He's burning calories. So what we're getting at here is he's not going to burn any calories until he first goes running. Okay? Now what's the direction? Well, it says the more he goes running. We can assume the more he goes running, as his running is increasing, what's happening to his calories? The number of calories he's burning is also increasing. Are these going the same direction or opposite directions? They're going the same direction. When they're going the same direction, as we just saw on the last page, it's a positive correlation. Okay, so this is a positive correlation. It's going to look uphill. That's a positive correlation, like a positive slope. Okay, so that's the first example. Let's jump into the next example. Kayla's dentist told her that the more time she spends brushing her teeth each day, the fewer cavities she will have. Alright, so two things are happening in this situation. One, she spends time brushing her teeth, and two, she's getting cavities. Okay, now what is happening first and what's happening as a result? Well, the first thing that's happening is she's brushing her teeth. And specifically, it's time spent brushing teeth. Okay? And what's happening second? She's getting cavities. Hopefully not many, right? So what relationship is happening here? Well, if she doesn't spend any time brushing her teeth, she's going to get a lot of cavities, right? But if she spends a lot of time, her dentist is saying if she spends a lot of time brushing her teeth, as she increases that, what's going to happen to her cavities? They're going to go down. So are these the same direction? Nope, they are opposite direction. So this would be an example of a negative correlation. Okay, as one is getting bigger, as our x is getting bigger and bigger going this direction, the number of cavities she's getting is getting smaller. Okay, so it looks like that. I want you to do 8 on your own. Okay, so on the first 4, I basically list the things that are happening, and on the second 4, I don't list the things that are happening. You have to do that as well. Okay, so we'll be working on this some in class, and let me know if you have questions. May the force of math be with you.